That's me! You may remember that we talked about factoring quadratic trinomials when our a value is 1. But what happens when our a value is more than 1? For example, how do we factor this trinomial? Do you notice anything that the numbers have in common? All three numbers have the greatest common factor of 5. So we can factor out 5, which leaves us with 5 times the trinomial of x squared plus 3x plus 2. Now we can factor the trinomial that was in the parentheses and leave the 5 alone. What about this example? Do you see a greatest common factor here? We have a greatest common factor of 3. So we can factor out the 3, which leaves us with 3 times the trinomial x squared plus 4x plus 3. Now we can factor the trinomial that was in the parentheses and leave the 3 alone. But what do we do if we don't have a greatest common factor? Let's take this example. As you can see, we have no greatest common factor. We have to look at the factors of the a and c values, in this case 4 and 3. So let's make a table. Ta-da! Oh boy. Who else saw that coming? In this table, we list the possible factors of 4 and the possible factors of 3. And because b and c in our trinomial are both positive, the factors of c must be positive. Now we list our possible factorizations based on those factors and figure out what our possible middle terms would be. Remember that the order of these factors is important because the middle terms formed by the possible factorizations are different. Because the second row of factors and possible factorizations gives us the middle term we started with, it contains the correct factorization we are looking for. But it is also important to see that the second row also contains the correct factors of our a value. Remember, you can check your answers by multiplying those binomials and seeing if you get the original quadratic back. Let's see another example. First, we notice that our a value is negative. So let's make our lives a little easier and factor out a -1. Now we can factor the trinomial that is left in the parentheses. Once again, we can make a table. We list the possible factors of our a and c values, 4 and -5. And because our c value is negative, the factors of c must have different signs. Now we list out possible factorizations based on those factors and figure out what our possible middle terms would be. And again, remember that the order of these factors is important because the middle terms formed by the possible factorizations are different. Only the last row gives us the middle term we started with and contains the correct factors of our a value. But remember that we factored out a -1 in the beginning, so we will put a negative in front of our two binomials. I know this may seem complicated, but it's really not too bad. Let's consider this example. All we need to do is think about what two numbers we could use to multiply together to get our a value 14, and what two numbers we could multiply together to get our c value 15. We could use some combination of 14 and 1, or some combination of 7 and 2 to make 14. And we could use some combination of 15 and 1, or 3 and 5 to make 15. We will keep the numbers that make 14 with the x's on the left of our binomials, and the numbers that make 15 away from the x's on the right. Then we see what combination of those numbers gives us the middle term we need. Can you tell which one of these is the correct factorization? Thanks again for watching. See you next time on
Jackson, the Space Dog!
That's Me!